Madras, Professor V. Kamakoti, as the chief guest. He is a professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Madras. He led the team behind India's first RISC-V microprocessor, Shakti. Professor Kamakoti has been appointed as the chairperson of the task force on artificial intelligence to explore possibilities to leverage AI for development across various fields. He completed his bachelor's in computer science and engineering from University of Madras, followed by MS and PhD in the Department of Computer Science and Engineering from IIT Madras. Prior to joining his alma mater as a faculty, he completed 2 postdoctoral assignments at Supercomputer Education and Research Center, IISc Bengaluru, and IMS Chennai. He holds specialization in software for VLSI, reconfigurable systems design, and computer architecture. He's been awarded with several awards, including Abdul Kalam Technology Innovation National Fellowship 2020, IESA Techno Visionary Award 2018, IBM Faculty Award in 2016, and many more. I request Professor Kamakoti to inaugurate the workshop. So please.
Thank you, Ms. Vasundhara. It's very exciting to be part of this very, very important workshop, specifically that touches environment. Today, what we need is a safe place to live, and that is going to be ensured. If at all there is going to be a technology intervention, this is going to be ensured by this type of efforts, where scientists, technologists, government, and the public come together to solve a problem which is actually becoming a very burning issue. So it is a very right time, and Santosh Vishwakarma in Indian history. Vishwakarma has been one of the world's best architects. Santosh, thank you very much for inviting me, and you have architected this workshop so very well, and I'm sure this is going to be a great success. Let me just start off with AI, which is now becoming sort of very, very, very big in across everywhere that you touch. For example, a typical AI course in IIT is taken by almost every undergraduate and postgraduate student. They enter IITs today, they go out with at least one AI course in their mark sheet. So AI is becoming very, very important because there is a very big market out, and we all believe that AI as a technology, as a subject, as a new field is going to basically give us something which is going to bring us a bigger ease of living. It is going to be a socio-economic transformer, and probably Industry 4 will be driven by AI. So with this as a point, there are a lot of efforts globally on what we call as AI for all, AI for good, etc. And the government of India had actually recognized this in a different way, a slightly different way, wherein today AI is driven by data, and this data essentially is going to be delivered by cyber physical systems. Cyber physical systems are going to be the primary or probably the major source of data on which AI systems are going to be built upon, either on the edge systems or on the cloud. And that is going to, if at all there is going to be a socio-economic transform because of AI, this is going to be one of the prime drivers. Around 4 years before, the government had recognized this, and through the Department of Science and Technology, had started what we call as the National Mission on Interdisciplinary Cyber Physical System, with an outlay of close to $500 million, around 3,500 crores of Indian rupees. This was announced by the government of India, and this national mission started a couple of years before. And again, thanks to this pandemic, we are going slow but very steady on this. So what does this interdisciplinary cyber physical system aim at? There are all, so if you look at cyber physical systems today, it covers all from A for agriculture to O for ocean engineering, all aspects of current day technology, and also futuristic technology, including quantum and post CMOS sensors, which are going to be not just complementary metal oxide silicon, but it are going to be post-silicon type of sensors. So it looks at variety of fields, both at the current technology and also on the futuristic stage. Keeping this in mind, the National Committee on Cyber Physical System has now enabled technology innovation hubs in almost all the IITs and some of the triple IITs. And close to 26 technology innovation hubs have been set up. And to give a different flavor to this entire effort, the complete vision of this mission is to basically get out products that will be commercialized and be in the market, and that will enable the transformation. So it is not that we are just concentrating on research, but what we term as translational research, which basically takes our idea to the market. And so all these technology innovation hubs have been mandated to evolve process procedures which will essentially convert these important ideas that come both from the academia, young entrepreneurs, and also major industries, and quickly accelerate so that they become solutions or products that could be actually sold and the end user get benefit out of it. So this is the very, very noble idea the mission actually had imbibed. And then, so 26 technology innovation hubs have started. And to enable this translation research, all these technology innovation hubs are opened as a Section 8 company. So this essentially means an industry flavor is brought in there. A Section 8 company in Indian, according to Indian laws, or as a company which is a not-for-profit company, which can basically enable multiple activities, much more oriented towards this translation research, right? So the entire effort is to bring in sustainable socio-economic reforms through this technological intervention and this translational work that need to be undertaken by these hubs. And so each of these hubs are given targets. The targets are fourfold. One thing is first research. If somebody has an idea, there should be a way by which the hub enables the person to basically go to a prototype stage. So DST has a scheme called Prayas, which essentially enables the person to actually quickly convert into a prototype. Now, the next one is basically the entrepreneurship, where we have a seed support system. Once there is an idea, a startup is basically formed. There is an incubation that happens, and the startup is actually mentored so that they basically can translate this idea into a proof of concept. And then we have also acceleration scheme, what we call as a DIAL scheme, where a proof of concept now goes up to a TRL level 7, 8, and then it's a technology readiness level 7, 8, and then it basically goes into the industry and commercialize it. We also have, so these are the different steps which are mandated for the technology innovation hub. Now we have the entrepreneurship scheme, we have the research scheme, and then very importantly, we want this to be an international collaboration, and that is where this workshop fits in very, very appropriately. So we are looking at multiple international collaboration. That is, every hub today has to look at around 10 unique international collaborations. Every hub is assigned an area, like IIT Indo has this particular area. Every hub has this. And so with 26 hubs, we are looking at around 250 solid international collaborations on translational research related to cyber physical system in the next 5 years. And then most importantly, we are also looking at capacity building, where we encourage young entrepreneurs to come into the system, mentor them so that they become good entrepreneurs. We also give fellowships for undergraduate, postgraduate, and postdoctoral students so that we train them and give them an opportunity to become an entrepreneur and also learn the trick of translating an idea that is on paper into a product. So these are some of the important targets that are set up by this national mission. Why I want to mention that, because there is, as the mandate of what was mentioned during the inaugural address by Santosh and the other speakers, it is very, very important that we already have this national mission. It is orienting them towards the entrepreneurship, international collaboration, research and prototype, and all that needs to make products which will essentially be a socio-economic transformer globally. Now, I want to bring in some very interesting case studies which have significant impact on the environment, which is taken up by multiple hubs. Today, I just want to give you a global picture here of almost all the 26 hubs here and take this case study. One is, of course, agriculture. Agriculture is very, very important for the environment, and it has a very strong relationship to health. So there is a concerted effort by the hubs to do a program, what we call as regenerative agriculture stack architecture. We call it RASA. RASA in Sanskrit essentially means essence, right? So so this is basically driven by community natural farming, and where the whole effort is to create a test bed wherein startups can basically, startups in this area or big industry in this area can basically come and participate, put their technology there with the consent of the farmers, and basically, evaluate the technology and see how effective it is there, with subject to them adhering to the natural farming. Natural farming means no chemical fertilizers or pesticides, but basically natural pest repellents and natural manure. And that is where we have started this effort. This has been experimented by the government of Andhra Pradesh to around 600,000 farmers, and it has been a phenomenal success, wherein there is a noble vision of our Honorable Prime Minister Modi ji on doubling the farmers' income. And this has the effort that we have taken in Andhra Pradesh has really seen that there is a doubling of the farmer income, actually 2.5 times, wherein even in, so India is, we have unity in diversity. So we have very different climatic conditions. Even within a particular state, we have places where we have excess rainfall, we have normal rainfall, and also deficient rainfall. Even in places with deficient rainfall, the natural farming principles have basically seen to it that there could be a 365-day crop harvesting and 365 days of farming that could happen there. And that is becoming extremely crucial, and specifically with respect to the amount of income generated by the farmer. To scale up this technology, so we have looked at 600,000 farmers, but now to scale up this technology, we need quite a bit of technical interventions, and that is where cyber physical systems come in a very big way. So things like, broad area moisture sensing, drone-based crop inspection, small micro robotic tractors which can go inside a farm and deweed. For example, we have grape orchards in Hyderabad, Andhra. So the pest repellent has to be sprayed from bottom, right? It has to it cannot be sprayed from top. So we need small micro vehicles which are autonomous, which can basically go ahead and spray these things, right? So there are a lot of robotics also involved here, and then of course a heavy IT intervention in terms of dissemination of natural farming principles to the farmer, taking up feedback. A lot of technology in basically even very interestingly, computational fluid finite element analysis is very necessary today, because there's an effort to make the natural manure, which is basically cow dung and cow urine, which is very important for natural farming, into small capsules which can be completely spread in the farm. And this essentially enables quick transportation, etc. And how the capsule is formed, if evaluating the efficiency of these capsules, involve as much as solving some differential equations and some finite element analysis. So this is where the technology actually starts coming close to the way of living. And so this is one major effort in agriculture, and this has direct relation to the health. Right today, we as health, personally in my family, I have lost two young cousins. They are teetotalers, no drinking, no smoking, but to cancer. The only thing is because of this pesticides and chemical food. So that is a big movement today, and good realization that we need to go in for this community natural farming. And one part where health becomes very crucial is, suppose a very interesting product today that we can think of is to have a small dongle or something, or a small sensor on your mobile phone, and you point it onto an object, and that will say whether there is chemicals there in that object or not. So this is some it's going to be a very tough project, but it's going to be very important project. So this is where we really want the environmental issues to become part and parcel of environmental monitoring in some way. Chemical fertilizers and soil health is a very important environmental issue, and this is how we were trying to bring them together. And this is something very exciting, and we also invite all who are present here. It is going to be a big effort, and I'll also keep all of you posted, and even South Korean delegates who are here. We invite you to participate in this major event. The next, of course, is the smart environmental monitoring, which has been in place today. Simple things like air pollution, water pollution, and this, where we have a network of sensors and basically collect these values across the city or across everywhere, and see if there is going to be an increase in some level, decrease in the quality of air, decrease in the quality of water, and natural resource monitoring. So this is also becoming extremely important. The third is, of course, the natural resource distribution. Today, gas, electricity, water are three important distribution today, which will have direct or indirect impact on the environment. So there are many efforts on the smart grids, and whenever you do something, there's always something to improve upon. So especially water distribution, safe water distribution, and also controlled irrigation today. So if you look at rice intensification, the effort essentially says that with 20% of the current water consumption, we could actually triple the yield, provided there are very good monitoring happens. And this monitoring can be very much enabled by cyber physical systems. And that is also becoming a very important goal here. So natural resource distribution is going to be a very big agenda point under, and many hubs will be involved in this natural resource distribution. And all these things today, if it has to be successful from a technology point of view, we need communication. And that is where we look at, we need large scale communication, not 1 byte, 2 byte that we are seeing here. And that is where we are dependent upon the next generation computing communication, namely 5G. Specifically, India has realized this quite some time before, and with 10 institutions together, they have formed what we call as India's 5G testbed. And as a part of this 5G testbed, specifically with respect to environment, we have got something called 5GI, which is 5G India standard. And this standard has been approved by the International Telecommunication Union, ITU. And so this is a approved Indian standard. Of course, people have to, the telcos have to adopt this standard and implement. But this gives a very important achievement of this standard is that we get large coverage, right? And low mobility, large coverage. By mean that we could go with the 5G base station, we can go up to 6 kilometers of coverage. That essentially means that we are halving the total amount of electronic hardware that we are trying to put here in terms of base stations or small cells, etc. At the same time, we are also giving a good coverage today. Even at places where it is not reachable for a fiber or electronics, or there is no conventional source of power. Now we are giving it a large by giving a large coverage. We aspire to cover the entire India, and this is extremely important for our rural India, and that is going to. So we are consuming by this standard. We are consuming less power. We are trying to reduce the number of base stations and electronic hardware, which is also very important because e-waste is going to become a very important criteria as we proceed. And so that has a big impact on environment. And we are enabling this lot of narrowband IoT that could come because of this. So 5Gi is a very important green deployment, and that needs to come up. And we are making all earnest attempt to see that 5Gi is in place. The last, Santosh, how much time I have?
Yeah, we will love to have you, sir. Another 5 minutes.
Yeah, sure. Okay. So the last important thing is this global coordination. India is a very big consumer market. I need not tell that because we have a 140 crore population, in which around 80% already have mobile, and there is a huge and India is also a gold mine for problem definitions, right? So we have different varieties of problems to solve, and that is something, right? So if you, for a very simple example, if you go to one of India's largest eye hospital, right, and go and ask any type of eye disease, you go to any doctor in that, for example, Shankar Netralaya, that is a very important hospital across the country. You ask the doctor any eye disease, how many such operations you have done, or how many such surgeries you have done. He'll say some 5,000, 6,000. So that is the wealth of data that we have. That is the amount of expertise one can develop by working in India and working in areas that are close to, living, day-to-day living, especially health. Similarly, in every domain. So this is where the global coordination becomes a win-win. So to enable this particular aspect, the national mission has introduced something called a grand challenge competition. Every hub will be doing a grand challenge competition on their areas of expertise, and wherein the thrust will be to find out problems that in India that could be solved by having some products that will become a socio-economic transformer, and that will improve the ease of living. And that is the entire intention. So, for example, IIT Madras Technology Innovation Hub, we call it Pravartak. From IIT Madras, we are looking at sensors, networking, actuators, and control systems. We call it SNACS, SNACS. We now have we are now announced a grand challenge. It is in the abstract submission is going on now. This is in collaboration with Sony, Japan, where we are. There is a very excellent board called S-Presence there. S-Presence is a sensor board. A very, very interesting board. And we are now, the mission of this grand challenge is to have sensing solutions for Bharat, right? So, so any sensor-based solutions, and we already got around 350 registrations, or 350 teams have registered, which essentially means around 1,000 people are going to participate. And from that, we are basically getting the top people out. We are enabling them to become an entrepreneur, and then if their idea is successful, essentially translate into a product. So now we have an ecosystem by which we spot the talent, take out, get the good solutions and translate it to product. And that is where, the collaboration also matters. Sony is very excited about that. So this is where, and the capacity that we build also is very important, because many international collaborations today have their research R&D officers in India, and they are also looking for good talent. And especially these areas, the talent essentially comes when you work on the field. Whatever we teach, right? I have been running the microprocessor program. We had 3 successful tapeouts of microprocessor within the last 2 years. The day my team actually booted the microprocessor, and I was also involved, my entire way of teaching computer architecture has changed. So what I'm trying to tell is, we need human capacity, human capability that has actually touched the field and made systems that work. And that is what this mission will enable. And the international collaboration can benefit out of it. So I want to end it with something specific to Korea. So Samsung is collaborating in a very big way with IIT Madras. So we are setting up what we call as a Samsung Innovation Campus under our Technology Innovation Hub, which will be looking at multiple sensing and networking and also control system solutions for many of many, not just Samsung specific products, but in general we are going to explore and those things which would be of great benefit to the ease of living again. So that is something, and we are very excited because Samsung has a very good penetration. So just I count many of these, Sony, Samsung, etc. They have consumer electronics, which essentially have a very close association with the human. So we have at least say 3-4 Samsung or Sony products in India, in every home here. So that way, this collaboration will be much more fruitful there. So thanks for this opportunity. I thought I need to give a big picture of where India, we are trying to push the cyber physical systems. And I'm sure there's everything finally lands up with environment. We need a good environment to live. We are earning for living properly. So I think that's the fundamental. So everything that we do finally has an impact on the environment, and we are conscious about it. And certainly this workshop is going to give more technical insights into this. Thank you very much, Santosh, for calling me, and Ajay also for calling me. And I hope you have a very technically rewarding next 5 days of your workshop. Thank you very much.